Okay, so yeah, this is the title of my presentation today, From Landscape to Consumption, a GIS-based approach to ancient soil demand. That is a talk extracted by my postdoc that finished last February at the University of Groningen. The theoretical background of presentation of today is more or less the one that Carlo already showed. But I'm maybe more inside processualism than Carlo, because the topic of today is about a quantitative approach to archaeology, to a historical question, and the starting point is the work of David Clark and of the processualism, analytical archaeology. So this idea that, yes, archaeology is a historical science, but is also a mathematical science. So the numbers are important for better understand the ancient society. Of course, this theoretical background, the processualism have a lot of criticism, as already Carlo pointed out. For this reason, I also combine this point of view with the one that coming from postmodernity. In a very interesting book of Edoardo Vanni, the author show how exists a present dimension that contributes to the creation of the data. So it's clear that we have some idea that coming from our contemporaneity, and that we put inside our reconstruction. So it is important to explain the epistemology position and also the way of thinking, the present way of thinking of our researcher, to better understand how he create the data about ancient time. So between this tension, I think that the solution and the goal of my research is not to decide what was the ancient situation of a landscape, of a community behavior, or so on, but is to create a frame of reference, so an hypothetical reconstruction onto which someone can visualizing the archaeological data and reflect on how was the possibility of this archaeological data represent a real ancient situation. So in other words, as pointed out by Binford, it is important to create a frame of reference, a general background of knowledge, onto which single case study, the post-processual micro stories, can verify with excavation, specific study, and so on. So this is the theoretical background, and the general topic of my research was and is this idea according to which looking in the landscape, and especially in the way of ancient community exploit a landscape, it is possible to better understand the society. It's not a new idea, it's more or less a simple situation. And this is the typical idea of kind of Marxist archaeology, or about the political economic school, like the one of Timothy Earle for prehistory and etc. As many of you already knows, I for a long time I'm work on agriculture, But today I want to show you another kind of exploitation of landscape, the one connected with the sea, and especially to the production of a specific resource, the salt. This is, as already told, extracted by a general project carried out by University of Groningen between 2021 and 2026. The name of the project is Salt and Power. And inside this project, we want to test the specific weight of salt exploitation inside the social dynamic of development of first city and first urban state. In the specific case of this talk, I want to show you my work that is find a way to quantify, so to reconstruction the numerical importance of this resource inside the production of ancient community, to better understand the social political dimension linked to the sodium exploitation. Why sodium is important in ancient time more than in modern? Because there are a lot of use that we show in a second. But before going inside the salt uses, we need to highlight the problem of quantify this demand directly. The first problem is that there are a lack of clear archaeological evidence. Also, the salt is a soluble resource, so disappear at a certain point. The second problem is that a significant number of study about this subject is not yet sufficient. So there are different point of view that can be both true or both false. So there are high degree of relativism in this side of study. So it is very difficult to quantify directly the salt demand. This because specific factor to be quantified. For example, in the ancient techniques of production, the briquetage, that is the boiling of brine in a specific kiln, to quantify directly the amount of salt that can be produced, you need to know concentration of salt in the water that change in different regions. You also have to find a way to estimate the efficiency of evaporation process that have inside this number of a lot of other factors like the condition, the environmental condition, the amount of energy employed, the labor of people involved, and so on. So this is difficult to obtain a clear number that you can say, okay, this site produce with briquetage this amount of salt. Last but not least, the size of the container in which the brine was boiled also affected the specific number of salt production. So you can see it's not easy to directly translate this work procedure in a specific number. The situation is more complex in the salt work, that is the update of salt production, because you need to know size and extent of the saline, how in detail production cycle works and quantity of salt produced. So is a big problem. What is the solution? Because exists a solution, is to do this indirectly, assuming that a community are able to solve the salt demand. So to understand how much salt was produced by a community, one can calculate, that is easier, the salt, the necessity of salt in different production, because we have a lot of study about it. How was the usage of salt is a lot that also Homer in the Iliad state that this resource coming from the gods. So salt was used, for example, for nutritional source like people and animals, but also in food practice. Was used for preservation of meat, fish, as stated by agronomists in a lot of their book, but also used in preparation of specific kind of food, bread, cheese, but also vegetables in brine. That is, for example, the only way in which olive can be edible. But also, the salt was used in ancient craftsmanship. For example, we know that salt can be used inside the pottery dough to change the insulation property of the clay, but also used in tanned hides or textile dyeing, because the possibility of kill the bacteria or the preservation property of this resource is useful for this kind of industry, for tanned hide and for fixing the color on textile. Last but not least, the salt was used for medical application inside a lot of ritual practice of ancient time. In other words, was also an exchange medium inside the general economic dynamic of ancient community. For this amount of uses, is not surprised that during the story, a lot of colleagues try to quantify the specific salt quantity inside these different uses. For example, we know that for craftsmanship, the salt is around 35 or 45% of weight of the leather that have to work. We know the salt needed in food preparation. In cheese, between 10 and 40 grams of salt for 1 liter of milk was used. More or less the same quantity in the bread. For food preservation, there are different idea of percentage of salt compared to the weight of food to be presented that go between 30 and 18% according to different author. It's the same for the brine. We know that today we use 1 kilo of salt for 1 kilo from 1 liter of water, but in ancient time this value was higher. Columella size that will be realistic around 2 kilos of salt for 1 liter of water, but other authors say also until 35. That is exaggerated, but to show this idea of for the Roman of how much important salt is inside different industries. If for this preparation the study are more or less not always all agree, we have more data about the human and animal nutritional requirement of salt. There are a lot of studies that we see summarized here in the slide. For my work, I use an average between these and says that more or less in a year, a person consumes 2.5 kilo of salt. A cow used 21.5 kilo, and a sheep or a sheep 4.5 kilo of salt. So for quantify the salt demand indirectly, we need to know for a community the number of people, the animal presence, the meat that they have to preserve, bread and cheese that they have to produce. I choose only these uses of salt because are the one that have the most deeper study about this topic, or have the possibility to obtain easier to the other uses of salt the data that you need to make this estimate. Where I can find this, I start thinking where I can find this this kind of data. Surprise, surprise, in my PhD, I do a work in which this kind of data were calculated thanks to GIS model of land evaluation. That is a technique that establishes the propensity of a landscape to different activity according to the number of factors that afflicted negatively or positively this specific use. So, thanks to land evaluation, you can reconstruct a suitability GIS model and then calculate the agropastoral system. Thanks to the agropastoral system, that is the amount of different hectare of a landscape used for agriculture or pasture, you can make a simulation in which you can obtain all the data that you need to make soil demand. So now I show you how this GIS approach works. The input of the model, of course, are para-environmental data like coring, pollen diagrams, or archaeological data, and agronomic studies that give us the information about the agricultural and pastoral techniques, but also to the resource management dynamic inside the specific time. Climate data also affect the agropastoral suitability of a landscape, so also climate data go inside the model that are built on a simple DTM of 10 meter of resolution. So it's completely digital, this model, and are built inside a GIS system, in my specific case, ArcGIS. Then the tool that I used to build this model is more or less very easy, simple one, are more or less all raster cell-based analysis, because the goal of the model is for each factor built a raster composed of multiple cells. Each of cell contain the suitability value on a scale that comes from 1 that is poor to 10 that is optimum, according to the suitability of agropastoral exploitation for a specific factor. For example, the slope, the elevation, the aspect, the geology, and so on. I did this analysis for each factor according to the specific agronomic necessity of the plant attested inside my study area, that are the Mediterranean plant polyculture assemblage, so cereal, olive, vine, and legumes. How's work the specific this step of model built? I show you for matter of time only the one on of grasses, but more or less the procedure is the same. For example, to build the factor map of slope, starting from the agronomic knowledge about the different percentage of slope that affect the best agricultural activities, I translate the different percentage in a scale of value. For example, we know that up to 35% is not convenient the workability of a land, or you have to invest a lot of time to make terrace or to modify the landscape. So until 35, the suitability value decrease, starting from a optimum situation, that is until 10%, decrease until become not convenient. So inside the GIS, you use slope tool and organize obtain this raster map of slope, and then reclassify according to the suitability value in a factor map. And the same for all the factor. For example, the elevation, starting from them, you reclassify the map according to the idea that every 100 meter of increase of elevation, the timing of blooming of plant decrease. You can translate this agricultural knowledge in a mathematical scale. So every 100 meter, your suitability value decrease of 1 point. So you reclassify your dam in a classes of 100 meter each, and then reclassify again in a factor map according to the valued as suitability. This is the procedure for each factor, no? So exposure, according to the knowledge of photosynthesis, so the role of the sun inside the blooming and the development of vegetable species, you can use aspect tool inside your GIS system, and then obtain a reclassify factor map. For geological soil, the situation is a bit different, because if there are not, like in my study area, an already available digital map, you have to digitalize it. But when you obtain your raster map of a factor, you can reclassify according to the geology of soil. Because in agriculture, at certain point, because I work on the prehistoric and protohistoric time, the knowledge of agriculture change, because the plug become iron and not anymore only made by wood. At certain point, you can make a different scenario. For example, in this specific case, at certain point, the clay soil become more suitable. Because from the Iron Age, the presence of iron tool start to make this soil more workability than before. So you can also make this dynamic model, as we will see in the second part of this presentation. But yeah, from a methodological point of view, you starting from your input, convert in different way in a raster map, then reclassify according to suitability value. The same for the land capability, that give you a lot, is a modern time map, this, but give you a lot of information about soil that can be useful for your reconstruction. For example, the rockness, the deeper, and yeah, all the chemistry data according to the soil that are not present inside the geological map. So once this map was digitalized, then can be reclassified. For the erosion, I use a specific classification, that is the one proposed by Davidson in 90s, and also by Emery Farinetti in 10 years ago, that is linked to the slope. According to this classification, more are slope of a terrain, more this surface will be eroded by atmospheric factors. So starting from the slope map, according to the four classes of erosion proposed by the authors, you can do reclassification once again, obtain your factor map. For distance from the water, the same, because the presence too close to the water is not good for agriculture, but stay too distant is the same, not good. Starting from the river of an area, you can make a buffer analysis and say that between different distance you have different degree of suitability, and then reclassify according to this. In this specific case, the optimum is between 100 and 500 meters. Okay, but not the best is between until 1 kilometer. More than 1 kilometer for a river, there is not suitability. Last factor is also the degree of humidity inside a land, for the same reason, because too much water can be bad for a plant. I calculate using the algorithm that already discussion by Carlo, the topographic wetness index inside the ArcGIS, and then obtain a map in which each cell have the percentage of humidity inside it, or at least a model of this, and so can say, okay, until 3 is good, and more than 10, that is more or less the degree of the topographic wetness index of the area in which I'm, of the lake or the river in which I am already know that there are the water, say is not good. Once obtained, this map can be for the last time reclassify according to the value. So at this point I have a single factor map for each factor that I've considered, but all the factors work together to define the agropastoral suitability of a land, not only one, but they don't have the same weight inside the choose of ancient agriculture, and also they don't have the same weight in the different climatic condition. For example, in wet situation, the factor linked to the water, and in the specific case, the topographic wetness index and the distance from water, will be more important than in the dry area, or better, they are more present. There are more water inside the landscape, so the water factor have a weight better, play a major role inside the general definition of agropastoral system. For this reason, I apply a specific techniques coming from social science that are named analytical hierarchy process, that can be, thanks to comparison to different factors in a couple, you can calculate, thanks to mathematical operation, a specific weight expressed in percentage inside your model. So for each calculation, each species cultivated, I do two models, one from dry and one from wet period, according to the percentage that you can see in the table, and obtain 4 different model. That is the one for the cereal, the one from olive, grape, and so on. In the model, the greener area are the ones that are more suitable for agriculture. So there are a predictive model in which there are indicated in green the area that with more probability, if exploited by agricultural point of view, can be suitable and give a good production of this plant. But because in my case study there are all the species cultivated at the same time, there are another step. So I need to overlap all the map together. And I use weighted overlay tools inside ArcGIS that give me the possibility to assignate the percentage of weight of each factor inside the raster analysis. And I apply the percentage of presence inside paleobotanical record to give the specific weight of single cultivation. In this way, I obtain a final general model of agropastoral exploitation of a land. At this point, I can make an interpretation, always according to paleobotanical and archaeological data, and I say, in my scale of value, from 1 to 5 is not is unsuitable, so they are out of my model. The cell with value of 6 are used for pasture and wood and forestry, according to the percentage inside the paleobotanical record. So in this case, for example, in a certain moment, there was 70% of forestry, 30% of pasture. But this change in time, as we see in the case study. Then from 7 to 10, there are the agropastoral, the agricultural organization of the landscape, with different degree of suitability, moderate, marginally suitability, valued 7, until more suitability, the value 10. And this all the agricultural land was divided according to the once again paleobotanical data to different crops that can be produced here. And also here they can change this percentage in during the time to make more dynamic your model, because we already know agricultural plant change during the time according to historical and market modification. So once you have the model, you can also do a simulation of productivity and demographic estimates, because this is the goal of our simulation, because we need this data to make quantification of soil demand. So my simulation have this rule: the production of cereal, for example, change according to the degree of suitability of land. So starting from the marginal suitability of land, class 7, the seal in which my model have the presence of crop, if they have valued 7, they produce 2 quintals of cereal in a year. If they have value 8, 2.5. If they have value 9 or 10, 3 quintals of cereal for year. This total amount was divided in 6 parts, and 1 was kicked out about from the calculation for the sowing or for the next year. So the remain was convert in flour, so lose 25% of total, and then calculate the amount of bread that can be produced, and translate this in number of people, because we know, according to the nutritional studies and also made by a lot of colleagues for the ancient time, that a person need 1.82 quintals of bread in a year. So you can say, okay, with this, with the cultivation of cereal, the maximum possible number of people that can be sustained is this. The same can do with the olive, because you have the total amount of hectare of olive cultivation. You say, in my simulation, according to the work of Keswani for the Bronze Age of Cyprus, I decide that a number of a plant density of 40 trees per hectare. Each trees produce 8 kilo of olive year, and in different moment, the olive pressed was between 60 and 80%. For 1 liter of oil, you need 7 kilo of olive, and people require 25 liter of oil per year. So the model and the simulation can calculate also the number of people that can sustain with olive cultivation. Last but not least, there are the animal that can be domesticated and can be slaughtered and become food. For do this, according to the number of pasture present, we calculate the presence of different species according to archaeological data, then determine the number of units, the maximum number of units according to the requirement of different species of pasture, of extension of hectare. For example, we know that need 1.2 hectare for the of pasture, pig 0.2, and a goat and a sheep 0.12. Then decide the percentage of slaughter animal, the kilogram of meat they can produce, the protein, and then for kilo, and then also here the number of people that can be sustained according to the requirement of kilo of meat per year. But we also, because we need the number of cheese that can be produced, I calculate the total amount of milk that can be produced by animal, that are more or less 60 liter year. Also this give protein for people calculation, but also the cheese production according to the percentage of cheese production, around 50 and 17 percentage of total milk was used in cheese production. This is also according to the biological data about the lactose persistence in human. But okay, at the end, I, in my simulation, calculate that for 1 kilo of cheese, you need between 10 and 5 liter of milk. So, with all these calculation, it's possible to make the total soil demand quantification indirectly, because starting from your site, you can decide the exploited territory according to different spatial analysis. In my case, I used bubble method, but you can use Thyssen polygon, extent, or site catchment analysis, and yeah, what do you want? Then you can make the total calculation of cultivate field and pasture inside your model, and then obtain all the data as the simulation I show you, and then you can calculate the salt demand. Now I show you how this work in a specific case study, the Agostino in the first half of first millennium before Common Era, and how this is important for us, because I'm, like Carlo before of me told, consider myself not a mathematician or a GIS specialist, but an historian. So how this calculation of salt required for Tarquinia can be important for history of this first city in the central Italy, I show you in this part of presentation. In the first period, for example, you can see the site of Tarquinia, that is this one, have a lot of coastal sites that from bibliography we know that are linked to the salt production. And the salt, the amount of salt that can be demanded by the population of this first city was high quantity, is more or less 527 tons of salt. That is a lot, because I have to feed the animal, the food production, and also the people. In the second period, the situation changed also for the change of climatic situation. In this case, the number of the salt demand increased, and also increase the number of people inside the area. We have a lot of secondary center now, and we also have a general reorganization of the system. If you see, also according to the different kind of exploitation, we have, okay, the exploitation of landscape, of coastal landscape, but we also have a return in a high agricultural area, like the one of the site of Tuscania, and so on. So in this moment, the salt demand increase and remain the same also in the following period. Also decrease a bit, but it's a fluctuation of the model. It's more or less the same. Then what's happened in the last period, in which the Etruscan civilization is defined, the salt demand increase a lot according to the increase of population, animal, and industry. So compare, for example, also this site that can be also considered linked to the coastal exploitation or to the different kind of use of landscape. But remaining focus on the salt, we see that the demand of salt increase in all the period. And this is the conclusion of this case study. You can see there are a increase of the demand during the formative phase of proto-urban center of Tarquinia. Then there are a more or less a stasis, but a high quantity of demand. And then when the city and the early states of Etruscan be completely developed, increase again. This is only the salt demand linked to this specific requirement. We need to assume that is higher than the one I can calculate, because we have to put inside the model, I don't know how, but this is an update that can be also the kind of activity linked to the salt, for example, the industry of leather, other kind of food practice. So the demand of salt was higher than the one I proposed here. So, okay, this is mathematical reconstruction, but how become history? Become history because we know that salt was producing with briquetage, that is these techniques that use pot to fill it with brine and putting in specific kiln and to make evaporation. But this is a high consuming techniques, both in terms of labor, both in terms of results involved. Now, we made during the Salt and Power project an experiment that is now it's under publication, in which we try to quantify the total amount of energy, fuel, and and other stuff linked to these specific techniques, and we assume that is higher consuming. So it's not convenient from an ecological and economical point of view produce this amount of salt with these techniques. Otherwise, we don't have any more forest in the central Italy during first millennium. So, thanks to quantification of salt demand, we need to assume that at certain point in this period, something changed, and the community need to find another way to produce salt. What is this new way? Is the saltern, so another kind of activity to salt production. And this is also because we know the population continued to increase during the Etruscan and Roman time. So the salt demand continued to increase in all the period. So at certain point, they start to use the saltern. In last February, so February of 2025, we made an excavation in one of these coastal sites of Ager Tarquiniensis, in the specific the Saline di Tarquinia site, in which we found, according to the fourth period, so around 5 and 6 and 5 century before Common Era, a lot of activity that made the dune that separates the internal lagoon to the sea was working to fortify and modify the general aspect of the area. So we can assume that in this specific case of Saline di Tarquinia, but in general in all the cases in the site of the coastal, in this point, the production change. So, in conclusion, what we can say about this GIS-based model, I don't know why it doesn't work anymore. You can, conclusion. What's happened? Disappeared the conclusion, but yeah, okay, this one. Okay, I don't know why. You can see it? No. I don't know why. But there is the conclusion that I can see you without the slide. I don't know why. Maybe I'll try again. Sorry. So, you can see? No. Yeah, thank you. Sorry. The conclusion you can see with this. No. But it's not important. But I think for the conclusion without the slide is not a big problem. I think there are a good point that is of this model, that is the numerical possibility of translate the ancient behavior in historical reconstruction, that give you the possibility to reduce the way of relativism of qualitative analysis give. Of course, there are a lot of problems of using model. First, there are the problem of the model is a simplification, so you need to test it on the ground, or as Carlo told, apply a post-dictive approach at certain point. So you start with a model, try to see if works or not, then try again to obtain another one more performative. Of course, there are also the problem that I apply as I say in the starting of my talk, an approach that is high linked to the economy, to the idea of economic behavior of people that Carlo shows us is not always true. So, for example, can be interesting try to apply also other kind of reflection about our work. For example, I like very much this post-colonial approach that developed in archaeology in the last year. And the last but not least, find to make this model dynamics and using different scenario, as I did with different climatic situation, but also with different kind of social situation, maybe, I don't know. So this is a work in progress, a continuous work in progress of work. And yeah, I think it's all solved. Sorry for the technical problem, but yeah, I think that will be clear enough. Thank you.